Here we have a SAT math question. Okay, let's go with the information. Mary is making a rectangle whose perimeter is less than 100 inches. If the dimensions are integers, what is the largest possible area for the rectangle in square inches? Okay, we have some information about the perimeter of a rectangle which is made by Mary. There is a perimeter has to be less than 100 inches. When L represents the length of the rectangle and W represents the width of the rectangle, so the formula to get perimeter of the rectangle is going to be 2L positive 2W. Okay, now let me write the given stuff. That is, the perimeter has to be less than 100 inches, and the formula to get perimeter of rectangle is going to be 2L positive 2W, so which has to be less than 100 according to the information we have. So here this one, this one, this one. So for all the three terms, I have the greatest common divisor 2. So to simplify this inequality, we can divide all the terms by 2. Let me do it. So when I do so, this 2 will cancel out. Here 2 will cancel out. So then I'm getting L positive W, that is a sum of the length and width of the rectangle, is less than, when I divide 100 by 2, I'm getting 50. Okay, now what we can do is we can solve for W in this inequality. So for that we have to subtract L from both sides. When I subtract L from both sides, I'm getting W less than 50 negative L. According to the question, we have to find the largest possible area for the rectangle. Okay, we already know the formula to find area of rectangle, that is length times width. Since the formula to find area of rectangle is length times width, I'm going to multiply both sides of this inequality by L, so that I'll be getting length times width on the left side. Let me do it. L times W less than L times 50 negative L. Okay, so actually this L times W, that is length times width, represents the area of the rectangle. So instead of that, we can write area less than, we can distribute this L to this 50 and this negative L, then I'm getting 50L negative L square. So in my next step, what I can do is area less than, we can rearrange the terms of this expression. I'm going to write this negative L square at first, and then I'm writing 50L next. So that is, I'm writing this polynomial in standard form. So the variable with the largest expression should be written at first. Okay, now I'm going to assign a new variable for this expression negative L square positive 50L. Let me do it. That is, let y equals to negative L square positive 50L. Then this inequality will become area less than y, because we know that y is a variable which is equivalent to this expression. Okay, now we have to get the value of this y, so that we will be able to get the largest possible area of the rectangle. Since we have to get the largest possible area for the rectangle, we have to get the maximum value of this y. Okay, so how do we have to get the maximum value of this y? For that, we have to consider the quadratic function we have over here. So let me write it over here, y equals to negative L square positive 50L. So whenever we have a quadratic function defined by y, usually we define by y in terms of x, but here the quadratic function has been defined by y in terms of L. So whenever we have a quadratic function like this, its graph will be a vertical parabola. Since the leading coefficient is negative, so we'll be getting a open downward parabola. So always the vertex will be the maximum point of a open downward parabola. So the vertex will be writing the x coordinate, but instead of x, we have the variable L in our quadratic function. We can write L, and for y coordinate, we have the same y over here. So the vertex, the y coordinate will be maximum. So to get the maximum value of y in this inequality, what I have to do is I have to get the y value at the vertex of this parabola. So for that, let's consider the quadratic function in the form y equals to ax square positive bx or positive c. So comparing this and this, it's very clear at the place of x we have L in our problem. So when we have a quadratic function in this form, there is a formula to get the x coordinate of the vertex, which is x equals to negative b over 2a. But instead of x in our quadratic function, we have the variable L. So we can write L equals to negative. So b is the coefficient of x, but in our case, the coefficient, instead of b, we have 50, which is a coefficient of L. So negative 50 over 2 times. So the value of a is, the a is the coefficient of x square. So in our case, to get the value of a, we have to consider the coefficient of L square, that is negative 1. Let me write over here. So L equals to negative 50 over 2 times negative 1 is negative 2. So this negative will cancel out. When I divide 50 by 2, I am getting 25. Okay, now I've got the L coordinate of the vertex, that is 25. Now to get the y coordinate at the vertex of the parabola, I have to plug in L equals to 25 into this quadratic function. Okay, now let me do it. Negative 25 square positive 50 times 25. Okay, so y equals to negative 625. When I evaluate this one, and when I multiply 50 and 25, I'm getting 1250. So then I'm getting y equals to 625 when I combine negative 625 and positive 1250. So this is a y coordinate of the vertex of the parabola, and also this 625 is the maximum value of y. Okay, now so we can write the stuff over here, that is the area less than the maximum value of y is 625. So from this it's very clear. So the area of the rectangle has to be less than 625. So like even if I consider 624 or 623, so that's the maximum, I mean that's the largest possible area. But anyways, when I go over the answer choices, there is only one option, that is A, which contains a value which is less than 625. So we can decide the answer choice A is correct. But let's have a little more understanding on this one. So because we have a condition, that is the dimensions are integers. Dimensions means the length and the width of the rectangles are integers. Okay, so here from this calculation already I got the value of L, that is 25. So 25 is an integer. Okay, now to get the value of W, what I'm going to do is I'm going to plug in this 25 for L over here in this inequality. So when I do so, I'm getting W less than 50 negative 25. So then I'm getting W less than 50 negative 25 is just 25. Okay, now so W has to be an integer and also it has to be 25. So we can consider many integers which are less than 25, like W is equal to like 20, 20, 21, 22, 23, 24. In this way, we can consider many integer values which satisfy the inequality over here. But the area has to be larger. So, we have to find the largest possible area. Since we have to find the largest possible area, we have to get the maximum value of W. So, among these values, the maximum value of W is 24, which satisfies this inequality. So, now we already got it. That is L is equal to 25. And the W has to be 24. Actually, W has to be less than 25. Since both the dimensions have to be integers, so we have to consider the value of W, I mean integer value of W, which is less than 25. I consider the maximum integer value for W. So because we have to get the largest possible area. So 24 is the value for W. Okay, now let's get the area with these dimensions, 25 and 24. So there is length times width, then we get 25 times 24. So when I multiply them, I am getting 600. So the largest possible area of the rectangle with the dimensions of integers is 600. So we find 600 in answer choice A. So the correct answer choice for this question is A, 600.